So we're given that the line has equation y is equal to 3x minus 2. So we're told that when x is 3, we want to find out what y is, so we just plug in 3 for x, and we get that y is equal to 7. When x is equal to, when y is equal to 4, we want to find out what x is, so we plug in 4 here, get, and then solve to get 6 equals 3x, so x is equal to 2. The x and y intercepts, so the y-intercept clearly is 0, negative 2, because we have the y equals mx plus b form, and then to find the x-intercept, we replace y with 0 and solve, and that gives us 0 equals 3x minus 2, 2 equals 3x, so x is equal to 2/3, and the intercept then is 2/3, 0. The equation of a line parallel to this line that passes through the point 10, 10, well, it has to have slope 3. And so in point slope form, y minus 10 equals 3 times x minus 10. Or in slope intercept, y is equal to 3x. 3 times negative 10 is negative 30. We add 10 to both sides to get negative 20. The equation of a line perpendicular to this that passes through 10, 10. So now we know that the slope has to be equal to the negative reciprocal of the slope of the original line, which means that m is equal to negative 1/3. So we get y minus 10 equals negative 1/3 x minus 10, or y is equal to negative 1/3 x. This will give us plus 10 sides, and so we're going to end up with plus 10/3 plus 10, and that's the same as negative 1/3 x. When we combine these two, we're going to get 40 over 3, because the 10 becomes 30 over 3. Okay, if the point a squared lies on this line, find the value of a. So what that means is that we know that since y is equal to 3x minus 2, we get that a squared is equal to 3a minus 2, which means a squared minus 3a plus 2 equals 0. And therefore, factoring, we get a minus 2 times a minus 1. And so we get a is equal to 2, in which case we would get a squared is equal to 4. And that also would fall on the line y is equal to 3x minus 2. And then we also get a is equal to 1 and a squared is equal to 1, which also makes the equation y equals 3x minus 2 true. Okay, so now we're finding the equation of a line that has a y-intercept of 0b and an x-intercept of a 0. Well, immediately we can just plug into the intercept form, x over a plus y over b is equal to 1. If we want it in slope intercept, well, let's put it in standard form by multiplying by the least common multiple of a and b, which would be ab. That would give us that bx plus ay is equal to ab. So that would be standard form. If we want it in slope intercept, we would get ay is equal to negative bx plus ab. And dividing by y would give us y equals negative b over ax plus b. And again, this is the same b in this form that we see in the intercept form. Okay, the equation of a line that is perpendicular to the line in 2a and passes through the point 0,5. So that means that it has to have, since this line has a slope of negative b over a, the line here has to have a slope of a over b, so, and it passes through the point 0,5, so we get y minus 5 equals a over b times x minus 0, or just times x, or y is equal to a over b x plus 5. Okay, and then we have to add 10 to both. Continuing here, if a parabola has equation y equals x squared, if a line intersects the parabola at one point only, the 0.11, what is the equation of the line? Okay, so here's what we know. We know that the line has equation y minus 1 is equal to m times x minus 1, or y is equal to mx minus m plus 1. Since we know that these have to intersect with the parabola, we can set x squared equals mx minus m plus 1. Okay, so now we want to set this up to solve by completing the square. So we do x squared minus mx equals negative m plus 1. And to complete the square, we would add half of the coefficient of the x term, which would be negative m squared. So we'd add negative m over 2 squared to both sides. So we'd be adding m squared over 4. And then when we factor over here, we get x minus m over 2 squared is equal to this thing, which we'll rewrite as m squared over 4 minus m plus 1. Well, the only way we'll get only one solution is if this whole side is equal to 0, because we're going to end up either adding or subtracting that. And so in order for this to equal 0, we'd have to say that m squared over 4 minus m plus 1 equals 0. Or multiplying both sides by 4, we'd get m squared minus 4m plus 4 equals 0, which means that when factored, m minus 2 squared equals 0, so m would have to be equal to 2. So the equation for our line would then be y is equal to 2x, and since it has to pass through the point 1, it would have to have the y-intercept negative 1. So when we draw this here, if we have y equals x squared, sorry, terrible drawing, and 2x minus 1 would touch this parabola in just that one point exactly. All right. Okay, so now we have this situation where we have the points 4, 5, and 2, 1. So let's see, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, so roughly drawn grid. So we're over at the point 4, 5. So right around here. And we're also at the point 2, 1. And we have that these are adjacent vertices of a square. So we'd either go over like this, or we'd go over like this. Okay, and we want to find the coordinates of, let's call this point A, B, C, and D. And we also want to find the equations either of this line and this line, or this line and this line, and then we also want to find the equations of these two lines here. Okay, so first of all, this line here in the middle that connects 4, 5, and 2, 1, it's going to have a slope of 5 minus 1 over 4 minus 2. So that's going to be 4 over 2 is equal to 2. And it passes through the point 4, 5. So we have y minus 5 equals 2 times x minus 4. Or in slope-intercept form, we would get y is equal to 2x minus 8. We'd have to add 5. We'd get 2x minus 3. Okay. So then these two lines that are perpendicular to this side and that pass through either 2, 1 or 4, 5 would have a slope of the negative reciprocal of 2, so negative 1/2. So the line that goes through B and C would have equation y minus 5 equals negative 1/2 times x minus 4. And that would then become y is equal to negative 1/2 x. And we'd have a negative 1/2 times negative 4 would be positive 2. And then we'd add 5, so we'd have positive 7. And then we'd also have y minus, now going through the line that goes through a and d, which also passes through 2, 1. We'd have y minus 1 equals negative 1/2 times x minus 2. And in slope-intercept, that would give us y equals negative 1/2 x. This would give us positive 1 plus another 1 would give us positive 2. Okay. So a couple things. Now to find the coordinates of C and D, notice that when we went from our two original points, to go from 2, 1 to 4, 5, we had to go over 2 and up 4. Well, to be perpendicular to that, we had to go from here to get to C, we had to go over 4 and down 2, which meant that from 4, 5, we went over 4 and down 2, so we went from, so down 2. So that means that C is going to have coordinates 8, 3. And D will have coordinates 2 plus 4 and, 2 plus 4 and 1, our y coordinate minus 2. So that's going to be equal to point D, and that's going to be coordinates of 6, negative 1. Similarly, when we would go from our original points to A and B, we'd have to go left 4 and up 2. So we'd go from 4 minus 4, and we'd go 5 plus 2. That would give us point B, which would give us 0, 7. And to point A, we would go 2 plus 4 and 2 minus 4, and 1 plus 2, and that would give us our coordinates of point A, which would be equal to negative 2, 3. Okay. So then finally we want to find the equations of the lines that pass through CD and AB. So for CD, and again we know the slope is going to be 2, so we'd have y minus let's use point C, so y minus 3 equals 2 times x minus 8, or in slope-intercept form we'll get y is equal to, this will give us 2x minus 16, and then plus 3, 2x minus 13. And so then we also want to look at going through, so we went through point C, and we also want to look at the equation for the line that goes through A and B. And so there we would have, again, the same slope. So, and we'll use point A, we'll use B. Y minus 7 equals 2 times x minus 0, or y is equal to 2x plus 7. Okay, so we have all of our equations here. We have y equals negative 1/2 x plus 2, y equals negative 1/2 x plus 7, y minus 3 equals 2x, or y equals 2x minus 13, y equals 2x plus 7, and then we had y equals 2x minus 3. And all the answers depended on whether you chose the coordinates C and D or the coordinates A and B.